Hello everyone, you are welcome to lesson 2 of binomial probability. Okay, in our previous lesson, we looked at the binomial probability function, the condition that a binomial experiment should satisfy before we can regard that as a binomial probability distribution, and therefore will allow the use of the binomial probability function or formula. And we handle questions, okay, using the binomial probability function. However, you realize that in the question that we handled, we dealt with situations where your exact number of successes is given, either directly or indirectly. So it was directly in the sense that the question was stated in your success, indirectly in the sense that the question was stated in your failure. So you take your failure to your success and it will still be a specific value for your success. So we had x is equal to maybe 0, 1, 2, 3, what have you. So we're looking for a certain specific, only one value for x. Okay, in terms of either our success or our failure. However, in today's meeting, we are going to look at situations where the question will not give us an equation straight away. Okay, if you analyze, the question will be in an inequality form, talking about your x. Your number of successes will take inequality form. Then you move from the inequality towards the specific or the equation. Okay, because you can see certain keywords there, and I will break down the keywords to you. I know you understand already. We'll just do a quick revision on that when we get there. So if you look at what we are going to do, and the question before us, you can see at least, okay, at most. Okay, the previous lesson, we didn't look at least situation at most. We looked at specific value, exactly, or if you remove the exactly and maybe 5 hairs, 2 hairs, which I said is the same as what? Exactly 2 hairs, exactly 5 hairs. But here we don't see exactly there, but we rather see our number of successes qualified by at least and what? At most. So let's look at how to deal with at least questions and at most questions. Okay, quickly. All right, before we come to the questions, okay, themselves, okay, let's look at the statement that we have here, the at least and what and the at most. Okay, then so that when I start, okay, my point will be well made. Okay, so if let's say I say that x is at least 5, what am I trying to say? In terms of math, what statement, okay, am I trying to write? If I say x, let me write it here, x is at least, okay, 3. What does this imply if you want to take it to maths? If you know, you put up your hand. Okay, Prof. Hanifa.
It means x is greater than or equal to 3.
Perfect. Okay, well done. So x is greater than or equal to 3. Okay, so you please, do you all agree?
Yes, please.
Okay, so at least, okay, 3 means 3 is the floor. Okay, so you start with 3 and you go up. Okay, if the ceiling is infinite, then you continue forever. However, if the ceiling, okay, is somewhere, you have a ceiling, then you end there. Okay, but in these situations, you always have a ceiling. You have your starting value and your terminal value. Okay, so again, if I say that x is at most, okay, 3, what does that mean? If you know, again, you put up your hand. Hello, I'm waiting. Okay, Prof. Meziana.
X is less than or equal to 3.
Very good. X is less than or equal to 3. So this means the ceiling. When you say at most, it means that's the ceiling. So you can come down, you can't go up. At least means that's the floor. You can go up, you can't come down. Okay, so this means all the values of x, okay, less than or equal to 3. 3 is inclusive. Okay, so once you know this, then it means my work is going to be very easy. Okay, especially forming the inequality from the statement. Then I will add all that you need to know. the various technicalities. So okay, once again, let's take the question and check whether the question will allow the use of what binomial probability function or formula. So let's see, a coin is tossed 4 times. Okay, we know this question. Okay, indirectly we know it will satisfy. You have a fixed number of trials. Okay, the trials will be independent of each other. We also know that the probability of success will remain the same, okay, in each trial. And we equally know that, okay, I've mentioned 3. Which one is left? Let me see if you are following. A fixed number of trials I've mentioned. Okay, Prof. Natalie.
Each trial has only 2 outcomes.
Very good. And remember, I told you that is critical. It has 2 outcomes or
Or it can be reduced to 2 outcomes, a success or a
perfect.
failure.
Perfect, success or failure. Okay, so we are good to go. We know it satisfies. Okay, in fact, I'm saying this just because I know that we have new students. Otherwise, I would have moved because we all know per experience that this will satisfy. So once you know that it will satisfy, what do? Come and quote the formula. But the question is numbered, so it means your solution must be numbered and must be numbered accordingly. I've told you, okay, you have to desist from numbering your questions your own way or introducing your own question numbers. It is very, very risky. I've told you that. Okay, those of you who are under my voice for the first time, please, again, I just told you. Okay, if you are numbering, which you are supposed to number, if the question comes with a number, your solution equally must come with a number. So when you read the question, the first thing that you write is solution. If your question has a number, major question number, you write the major question number. So I'm presenting the solution to question number 3. I state that 3. Okay, do I have any general information that I can pick here? Yes, I know this is satisfying the binomial probability, and therefore I will need the binomial probability formula, okay, or function. So let me quote it as a general information, then I will move on. So in this case, I know I will need the binomial. Otherwise, somebody would have written, given number of trials is equal to 4. Then you come in. But we extract the number of trials along the line anyway, so you can choose not to write it. So in this case, it will be P. Let's quote the formula together. Hey.
P into brackets, X
No,
equals.
remember I just told you, don't say P into brackets.
Oh, sorry.
Probability of X is equal to X. That's how you read it. Is that clear?
Yes, please.
Okay, all right. Let's go. It's equal to
N equals N combination X.
N
I
combination
mean the whole
X.
class. So I was hearing only one voice.
N combination X.
P raised to
P
X.
exponent X.
And then
Q N minus X.
Am I right?
Yes. Yes.
Are you sure you don't see anything wrong with what I've written?
No,
the
please.
P is supposed to be small.
The
And
Q
Yes,
is in
so
the
you can
air.
see that there should be a tail. So this should come down, this should come down. Please take note. Oh, these are some of the petty things that you do and rob you of your marks. So please take note. I'm doing so. Once you've been able to correct me, you have no business not to correct yourself. So I'm going to do the right thing here. Take note. All right. Okay, so now we are going to get small p. So you can see that it's going beyond this line to the power x. Okay, oops. Okay, and your small q, okay, to the power n minus x. So now we've quoted the formula correctly. Okay, so in this formula, let's listen. The formula is telling us, Prof. Aduma.
Darkman, please. I don't see the difference between what you wrote and what.
Okay, the first one that I wrote, the P, the line here was ending on the same line as this. Okay, and it cannot be. Okay, you know that if you are writing, okay, your small p, so initially it was this, because I wrote it this way, n combination x. Okay, and so now it's supposed to be this.
Okay.
You get it?
Yes, please.
Okay, all right. Okay, so can I move on, my professors?
Yes, please.
Okay, so I was saying that once you quote the formula, I've told you, formulas, they talk. Listen to them. They will tell you the parameters that you are supposed to and look for or what you are supposed to do next. So in this case, we will need our n, we will need our p, our q, and we know by experience that the x will not be constant. Okay, but your n, your p, your q will be constant. So let's go and extract. When you are coming to write the bat, please take notes. Okay, when you are writing the bat, you are starting a, don't think because this is math you can write anything. Okay, you are starting a new sentence. Okay, so you start with a capital letter. So it's supposed to be capital B. Okay, so if you write small b, though when you write small b, it will not, okay, I mean, be costly. But we need to know the writing and do the writing, that's all. We won't deduct marks. You are not marking your English anyway, it's maths. Okay, but if you don't take care and you overlook that, it might affect you in a situation where English is being marked. So take note, that's why I need to draw your attention to that. So here n, which is our number of fixed trials, we have was 4. And again, I think I failed to address this in the previous, okay, what do you call the solution to the assignment, but I will say it. I equally advise when you are extracting, don't extract, okay, the information in column, extract it in row. Now you are using constraint, okay, paper, okay, where the space is provided. So maximize the use of the space. So what you can use one line, if you use what 3 lines for it, it's just a waste of space. Okay, so n is equal to 4p, which is our probability of success. And what are we going to take as our success? So here we are going to take head as our success. So the head is fixed. So I'll use p head. That's probability of obtaining a head. That's my success. And that is equal to 1/2. Okay, we know this one is fixed. For a coin to be any trial, you are going to get what? Your head, okay, probability of getting a head, obtaining a head to be 1/2. So comma, and the last one will be Q. Okay, so Q we know is equal to 1 minus P, okay, which will be 1 minus half. So that will give us what? Half. Okay, so assuming maybe you use each line, okay, for each, okay, information or parameter. Look at 1, 2, 3. You use 3 lines, and we have used what? 2 lines. In actual fact, you even have more space, so you can use only 1 line. Is my point well made?
Yes, please.
So don't extract in what? In columns. Always extract in row, if possible. So now we come to A. Okay, and when you are moving from this to A, you don't leave any line. It's when you are moving from one sub question to another sub question that you leave a line. But here I'm not moving from a sub. My first, okay, sub question is this, so I don't leave any line. So AI. Okay, what am I looking for? I don't write at least one head here. Okay, in actual fact, the whole of this goes with this. So it will be P, and I know by experience I'll write therefore. Okay, so P, okay, at least, okay, one head. So at least, probability of obtaining at least, okay, one head. Okay, and this will be equal to, in terms of x, this will give us P, okay, x. We said at least means was greater than or equal to. So it will be greater than or equal to this value here. So it will be greater than or equal to 1. Do you agree?
Yes, please.
My professors, who wants me to come again? Hello, my professors, are you there? Who wants me to come again? Okay, so it means you are all fine. We thank God. You are doing well. So now, this is all that we need to do. If you look at this, okay, remember your s can take integer values. Okay, in my definition, let me see, somebody has sent a chat. Okay, all right, noted, Christine. Okay, so now this is it. But be snappy, Christine, Prof. Christine. All right, okay, so this is it. Remember, if you are looking at this, a coin is tossed 4 times. So let me come and do, I will clear this also as my rough work. This is what I'm doing. So I know head, my success. Okay, tail, my failure. So I'll have 0, 1, 2, 3, 4. Okay, and this will equally give you 4, 3, 2, 1, 0. You agree, right? We did this in our previous meeting. So if you get
Yes,
0
please.
heads, it means you get 4 tails, 1 head, 3 tails, okay, and what have you. So in this case, if we are looking at x, and remember the x here is representing your success. So your success, you are looking at greater than or equal to 1. So it means you are considering this. Do you agree?
Yes, please.
Okay, so it means you have to go for a situation where s is equal to 1, s is equal to 2, s is equal to 3, s is equal to 4. So we are going to look at 4 application or use of the probability formula. So this will be equal to, okay, we know x is greater than or equal to 1. So we get p, x is equal to 1 plus, or p, another possibility will be x is equal to 2 plus, okay, p, x is equal to 3. I hope you are following my professors.
Yes, please.
Okay,
Yes,
so
please.
let me see if I can go back and move this one to this side a little so that I don't want this to, okay, assuming you are doing this and you have a spillover, let me take advantage. Okay, you come and write plus. Okay, so the next one will give us what? P, x is equal to what?
4.
X is equal to
4.
4.
4.
Okay, can we go beyond 4? Obviously, no. So you can see that, like I said, because your number of trials will be fixed, you will have a ceiling. Okay, you will have a ceiling. You don't go forever. Okay, so this is what we have. We know how to find Ps is equal to 1. We know how to find Ps is equal to 2, s equal to 3, s equal to 4. From our previous lesson, is that not it?
Yes, please.
Okay,
Yes,
so we are
please.
going to do each one, okay, but we'll do it together. We won't do them separately. We'll do it together, then come and add. Okay, so now this will be equal to, we know, Px is equal to, and this is why it is important. Let me again reiterate. This is why it is important to always write your equal to close to what? Your margin, or I should say, introduce your steps with equal to. You can see that there is a spillover. Assuming you wrote plus here and you brought the spillover here. Okay, I will ask myself, is this a spillover or it is the next, okay, step? Because your steps, I'm not able to identify them easily. But if you write equal to here, and there are spillovers, I know that because there is no equal to here, this is definitely a spillover, a continuation of this. Okay, so remember, I've advised you already. I'm saying this because we have new, okay, family members. Okay, so in this case, we go. X is equal to 1 means wherever I see x here, it is 1. But we already know our n, p, and q. So let's go and substitute. That will give us n is what? 4. So we are doing this one. This is 4 combination 1. My professors, I hope you are with me.
Yes,
Okay, so then your p is half. Okay, so it will be half to the power x. X here is 1 into, okay, half to what power? To the power n minus what? Minus x. So n is 4, x is what? 1. So that will be 3. 4 minus what? 1, 3. Then plus, we come and do this. X is equal to 2. So that will give us 4 combination 2. Okay, then 1 over 2. Okay, to what power? To the power 2, which is squared, into, again, your q is 1 over 2. To what power? It will be n minus what? X. So it will be 4 minus 2, which is 2. Okay, then plus our third one, so a spillover, which is this. Because there is no equal to, we can easily identify that as a spillover. So that will give you 4 combination 3. I hope you are with me, my professors.
Yes.
Okay, so did I write x? Okay, all right, supposed to be 3. Oops. Okay. So combination 3, then in brackets 1 over 2 to what power? Hey, let's go.
1.
3.
No, it's not 1. No, it should be 3, please. Your x, the power here will be 3. Then into 1 over 2 to what power? Now it will be 4 minus 3, which will be 1. Is that okay? Then
Yes.
are we done with all the terms? All the possible probabilities? No, we are left with the last one. So plus, let's go.
4 combination 4 into bracket 1 over 2 raised to 4
Okay.
into bracket 1 over 2 raised to the power 0.
Perfect. I hope you are with me.
Yes,
Yes.
please.
Okay, so now that we are able to get this, the rest will be very easy. You know where we are coming from. Okay, so let me clear this side and we go and continue there. Okay, so please, if you have any question, do ask. Okay, what we are doing here, I've told you this particular topic is very critical. You need to understand it. And now most of the questions are moving in this direction. Apart from the fact that it will be binomial probability, you also need a less than, greater than, as at least and at most situation. So if you get this, any question, you should be able to deal with it. Okay, so now let's go. The next step, you write close to the margin, so equal to, but you introduce that with equal to. Once it's a step, you are doing something to whatever that you have there, it becomes a step. So you always start with equal to. You are not writing exactly what you have there again, and you are altering it. Okay, you have your input in it, then it means you introduce. So the next one, it will be 4 combination 1, which you all know is 4. Okay, then half to the power 1, we know is what? Is half. Remember I said deal with the powers after substitution. Then half to the power 3 is what? 1 over 8. Okay, then plus our second one, what are we going to get? Okay, so Prof. Aduma.
Mr. Hackman, what I want to ask is, because it's EMAS, can't you like punch this like the whole?
No,
Okay.
I won't even allow you to land. No. Okay, so deal with the powers. Okay, remember when we were doing permutation and combination, I told you the situation that you can use your calculator straight away. You remember? So
Yes,
where
please.
you can use your calculator straight away, I will tell you, because I've told you your marks are also mine, your grades are also mine.
Yes,
All
please.
right. Okay, you are welcome. So deal with the powers, then so do it systematically in this way, subjective question. So the next one, let's go. Help me, my professors.
6. 36
Oops, what
times
happened?
1 over 4.
Okay, 6 into 1 over
1 over
4.
4. 1 over 4.
1 over 4. Okay, then plus. Okay, let me calm down because I realize it won't go there. Here plus
4
4.
over 8.
Okay, 4 into
1 on 8
1 on 8.
and 1 on 2.
1 on 2. The same as the first. Okay, so 10. So plus
1
Okay, you can choose not to write the 1 into.
1 on 16.
Okay, 1 on what? On 16. Then into 1 again. You can choose not to write that one, but just for explanation purposes. So now this will be equal to, you use your calculator to do this, just as I told you. Okay, so now you use your calculator to do each of the terms, not everything, no, I beg. So let's use our calculator to find each of this. So you know that, okay, this will go here too, so we get 1 over 4, am I right?
Yes, please.
Okay, then plus, the second term will give us?
3 on 8.
Okay, so 3 over 8. Okay, the third term?
1 on 4.
Okay, 1 on 4. And the last term, 1 on 16. Am I right?
Yes.
Okay,
Please.
so at this point, you can use your calculator. All correct.
Yes, sir.
Okay, so use your calculator and give me the value. Then we are done.
13 on 32.
13 on what?
32.
32. So that becomes our final answer. Afa. Now, professors, are you with me? All correct?
Yes, please.
Okay, great. All right, so if that's the case, then we can move on to the next question. Okay, so the next question, however, before we move,
I got 15.
15 over 16. The final
final
answer.
answer. Hey, so
Yes, I had 15
who
over
gave me this
16.
value? The person should own up. Who gave me this value?
Sir, please, I did. I made a mistake. Sorry.
Prof. Abba, are you the one?
Yes,
Did you
please.
use your head or your calculator before I say what I want to say?
Sir, please, I used multiplication for the first part instead of addition.
You didn't answer my question. I said, did you use your head or your calculator?
Yes, sir. No, I used my calculator.
Okay. Okay, then I can say what I want to say. Your calculator has a problem. All right, okay, so let's see. So please, you've done, take note, Prof. Abba, you've done, okay, this is the work. Don't let, okay, I mean, this take away any marks from your presentation. You are through with the major work is done. This one is just a calculator work. You can't get this correct and calculator work, get it wrong. That is a big error. So if that's the case, then let's go and do the, I will not even check because I know you will not, okay, get it wrong. So if you, unless you give me the reason to doubt, okay, anytime you give me an answer, I will think through before I write it. Okay, so you said what will be the final answer?
15/16.
15/16. Okay, all right, so this is what we have. Okay, so now we are going to look at a particular, okay, direction. And please let me say this at this point. Anytime you have at least, at most, we all know we are going to get an inequality for your x, not an equation directly. Okay, then the inequality can be in two directions. Always you have to check which direction will be ideal. Okay, so if you don't check, you will work harder but not smarter. However, you know, I've told you it is better to work smarter. All right, so this is what I mean by that. So we are going to look at an alternative approach. Okay, so this is it. We are looking at solution to what we have here. So we are still looking at, okay, AI, so AI, not II, forgive me. We are still looking at probability of, I want us to write something, P, okay, at least. Please, at this point, don't write, just listen. At least what? One head. Okay, I need your maximum attention. This will be equal to, again, you come and write, the meaning of what you have here is what? P, okay, X is greater than or equal to 1. That must be written. Okay, but now you know every inequality will have two directions. The direction in the question is what I call the direct direction. And we have the opposite direction. By that, this is what I mean. I said maximum attention. If I have a normal line, okay, I have, okay, maybe one here. Okay, the original normal line direction is this. That is x is greater than or equal to 1. Is that clear?
Yes, sir.
Okay, so let me call this normal line x so that I know that we are dealing with x values. Now you know that obviously there will be an opposite direction. Can you see that?
Yes, sir.
Okay, and the opposite direction will be, so this is x is what? Greater than or equal to 1. Oops. Okay, x is greater than or equal to 1. What will be the opposite direction? It will be x is strictly less than 1. Is that not it?
I'm lost.
You are lost. Okay, all right. Okay, so I'm saying that for every inequality, you have your direct direction and the opposite direction. I want you to know the opposite direction because I'm going to make use of the opposite direction at a point. And I cannot just, okay, say the opposite direction inequality without walking you through this. I want us to get the understanding of how to obtain the opposite direction rather than giving it to you directly, so that in case the question is twisted, you'll be able to deal with it because your foundation is strong. You get the point?
Yes, please.
Okay, so if I have x is always, if I have x is what? Greater than or equal to a, its opposite direction will be x is strictly less than a. If I am greater than or equal to 2, my opposite will be less than, okay, 2. I hope you are with me.
Yes, please.
Okay, so what if I have, okay, x is maybe greater than b? What will be the opposite direction?
X is less than or equal to B.
Perfect. So
B is
now, hey, somebody was saying something. So it will be x, the opposite will be, so you change this inequality. If it's greater than, the inequality will be less than or equal to. then your x will be there, then your b will be there. That's all. Is my point well made now, my professors?
Yes.
Okay, so always we need to look at what a particular direction. One direction usually will be ideal to go for, and by that, this is what I mean. Please, maximum attention once again. All right, so let's go. I'm going to clear this. Okay, well, once you've understood, okay, what I want to put across, now let's come to what I want us to do. Okay, great. After this, maybe we can go for our water break. Okay, so we know this. Okay, the set of possible outcomes. Okay, for your success, we have 0, 1, 2, 3, 4. Do you agree?
Yes, please.
So we can have P0, probability of obtaining no head, probability of obtaining 1 head, probability of obtaining 2 heads, probability of obtaining 3 heads, probability of obtaining 4 heads. This will be the probability of what? Of all the outcomes. But remember, as one of the axioms, okay, you were with me, okay, yesterday in Comat. Okay, we said the sum of what? The outcomes, all the outcomes in the sample space, probability of all the outcomes in the sample space should give us which value?
1.
1.
1.
Okay, so you know this. If you know this, then we are good to go. Very good. My work, okay, I wish you were here to see the smiles on my face, and it means my work is going to be easy. So it means P of 0, so P of 0 plus P of 1, okay, plus P of 2 plus P of 3 plus P of 4. Okay, then in this case, I'm talking about x is equal to 4. Okay, should be equal to 1. All correct.
Yes,
Yes.
please.
Okay, remember we said if we are looking at P at least 1, then it means we are looking at from here to here. Is that not it? At least 1 will be P1, P2, P3, what we did here up to P4.
Yes, sir.
Yes,
I don't
please.
want to use x is equal to x equal to just to save time. Okay, so I won't mention the x. So you should be able to relate. It's my point well made.
Yes, please.
Okay, so you can see that there is another direction, opposite direction, which is this. Okay, so my point is you can see that if I take this and make this one the subject, I can say that P at least 1, what I have here is at least 1. P at least 1. Okay, will be equal to 1 minus P0. Do you agree?
Yes, please.
Please, do you all agree now?
Yes, sir.
Okay, so can I say that this is equal to 1 minus P, okay, x is equal to 0. Should I come again?
Yes.
Who wants me to come again? This is the foundation. If you don't get this, going forward, we all struggle.
Please come
Okay.
again.
Okay,
Come
Prof.
again.
Adoma.
Please
Okay, I should come again. All right.
again.
From
Yes.
please, yes, no problem. Please, from where? I don't want to believe from the beginning.
The probably the possible
From the
outcome.
change of subject.
Yes, please. Okay, I
Okay,
understand that.
you understand it now.
I
Hey,
do.
Okay, so someone is now on board. Okay, so those who are not on board reduce by 1. Okay, so let's see. This is what we have. You agree this statement that probabilities of what all the outcomes, the sum should give us 1. Is that clear? And we also know that this is the same as P at least 1. So if this is P at least 1, we know that if you are making P at least 1 the subject, it will be 1 minus this. This will come here and it will be minus. Is that okay?
yes,
Yes,
please.
please.
Okay, so it is, remember I am using, okay, 0, is s is equal to 0, like I said. But I don't want to write s equal, this s equal to 1, s equal to s equal to 3, what have you. Okay, so but when I'm writing it in terms of x here, this I have to, because this is in terms of x, its relation here should also be in terms of x. So that's why I didn't write p, okay, 0, but I wrote s is equal to 0. Is that clear?
Yes, please.
So anytime, please take note, anytime in probability, we'll do it in core maths as well. Remember, I've told you should have done the core maths before doing this. Okay, but I can still teach for you to understand because I know you are smart. Okay, so this is it. This is a relation that you need to know under probability. Anytime you have P at least one, okay, let me write it here. P, I will clear it. P at least one. And this works for only at least one. It's always equal to 1 minus P none. And you can say that, oops. All right, okay. Don't worry, go back. And you can see that this is the same as the P0 is P, none means no head. You get it?
Yes, please.
Okay, so it is 1 minus P none, and none will be S is equal, no head, which will be S is equal to 0. So this is a statement that you need to have at your fingertips. Anytime you see at least one, use this relation. It's always easier, okay, in terms of calculation. Or better still, it is what? Ideal. Is my point well made now? So can I clear this? Can this go now?
Yes, please.
Okay, so now I am going to clear all that. Please, those who said you were not on board, are you on board now?
Yes, please.
Okay, so great, we thank God. Okay, so let me clear this. Okay, it has served its purpose. Oh, what is happening? You don't want to go. I'm coming. Oops. Okay. I'm coming. Give me some few seconds. I'll clear it. It should go. It will go no matter what. Okay. Oh, what is happening? Okay. All right. So, okay, this one too must go. It shouldn't be part of the solution. It's a statement that I made. Okay. All right. So thanks for your patience. Okay. So now it means this will be equal to 1 minus P0, x is equal to 0 will mean 4 combination 0, okay, into 1 over 2 to the power 0. I hope you are following.
Yes, please.
Okay, then into 1 over 2 to what power? To the power 4. Okay, I'll move on to the next slide, then we'll continue from there. Okay, so which will be equal to 1 minus, okay, 4 combination 0, any number combination 0 is 1. Do you agree?
Yes, please.
Okay, so it will be 1 times 1 over 2 to the power 0 will also give us 1. Am I right? Look at what
Yes,
we
Yes,
have
please.
here. Then 1 over 2 to the power 4 will give us 1 on 16. Am I right?
yes,
Yes,
please.
So
please.
1 on 16. So it means in effect we are going to get 1 minus 1 on what? On 16. As you mature, you could have written the 1 on 16. Oops, I wrote 6. 1 on 16 here straight away because it is 1, 1, 1. Okay, so now this will be equal to, okay, 15 on 16. Okay, was that not the same value that we had? Okay, from the first direction.
Yes.
Okay, so though I know, okay, it's obvious, between this and the first one, which one do you think is ideal? Ideal in the sense that
This
it
one.
saves you time, okay, and space. This one, is that not it?
Right.
Yes.
Okay, so when you took the other direction and the opposite direction, you know, anytime you are taking the opposite direction, it will be, so this is, let me, so remember it was P0, okay, plus P1, plus P2, plus P3, okay, plus P4, okay, is equal to 1. Let me write equal to 1 here. So we're looking at this. But we decided to take this direction because if you look at this direction, the function will be used 1. So if you use the opposite direction, then you should always subtract that function from 1. Okay, so going forward, you appreciate it better. Don't worry. This is the first example. So if at least you get, okay, some understanding from the explanation, that is okay for me for now. Okay, Prof. Amma.
Mr. Ackman, please, the alternative answer. See the second step, P into brackets X. The X there, is it the smaller X or the bigger one?
Are you still saying P into brackets?
Probability into brackets.
Mm.
So the X, I want to know if it's the bigger one or the smaller one.
Oh, you can use the bigger one because you can see that the first X that you then after that, when you are changing it, then you know this is the value of the smaller one.
Okay.
You get it. You know that whatever will be here. So it's like in actual fact, your inequality is this way. The first one was okay, X is equal to X, capital X, forgive me. Then now it will be X is greater than or equal to small x. Is that okay?
Yes, please. Thank
So
you.
whatever that you have there will be your smaller x, which will be your number of successes. Is that clear?
Yes,
Please, can
sir.
you come again?
I should come again. Okay, I said the first one in the where you have the equal to straight away, you quote the formula this way: capital S is equal to X. In some books, they even write just PX. Okay, so that if your X is 2, it will be P2. You get it? It's the same thing. You should know that the X that you have there is representing your number of successes. Okay, but because of the direction that we are coming from for consistency, this one is capital X is equal to small s. As for this one, no problem because that's where what we've been dealing with so far. Now we don't have equal to, but we have x is greater than or equal to small s. We have an inequality sign. We can also have x, okay, is less than or equal to, okay, small x. So instead of the equal to straight away, now we have the inequality sign or signs. Is it clear now?
Yes, please.
Okay, all right. Okay, so now, okay, we can go for our water break. Okay, so when we come back, then we come and build on our foundation. Okay, so welcome back from the water break. Okay, we are done with what AI. Let's go and look at AII. Okay, so AII. So I'm moving from a sub question to another sub question. So I will leave a line and go and write the question number II. Okay, II, therefore, what am I supposed to find? P, probability of obtaining at least 2 heads. So P, at least, okay, 2 heads. Okay, this will be equal to, so your first step, equal to, you want to work on this. This is the same as P. This at least means I'm dealing with an inequality. So it will be X, okay, greater than or equal to 2. Do you agree?
Yes, please.
Okay, very good. Now we want to see which direction will be ideal. So I am going to write, okay, whatever that so I think I can write so that this space will be free. So I will have 1, 2, 3, 4, okay, then 0, okay, my H, okay. Now if I'm looking at greater than or equal to 2, okay, then it means I'm looking at 2, 3, 4, am I right? So I will apply my function on 2, apply my function on 3, okay, then apply my function, okay, for 4. I hope you are with me.
Yes.
Okay, very good. Okay, so that means you apply your functions how many times?
3 times.
3 times. Now, let's look at the opposite direction. The opposite direction will be what is remaining, what is up. Okay, so that is 0 and 1. So 0 and 1, you apply your functions how many times?
Twice.
Twice, which is less than 3. Is that not it?
Yes.
The original direction. So because you are going to go for the opposite direction, it will be 1 minus P0, then minus P1. I hope you get my point. Or I should come again. Should I come again?
Yes, please.
Okay,
Yes.
so I don't want to use probability. So it should have been P0, okay, P1, okay, P2, P3, P4. Okay, the whole of this, if I sum, should give me 1. Is that clear? So this is equal to 1. the value if I sum the probabilities. But now, if I'm going this the original direction, the opposite direction will be up here. So that would be 0, then 1. If I'm going the opposite direction, I don't do P0, then P1. I have to come and subtract, okay, all the probability functions that I will use for each of them from 1. So this will be minus, I will move this one to this side. The P0 will come here, so it will be minus P0. Okay, then the P1 will also come down, so it will be minus P1. Is that okay?
Yes, sir.
Okay, so here we realize that the other direction will be better. So in actual fact, you can see that this direction, okay, is the same as, okay, Px is what? Less than or equal to 1. Do you agree?
Yes, sir.
Okay, so someone can write 1 minus P. I'm writing it just for explanation purposes. As you mature, you don't write it. You can move like the way I moved here. So this is the same as 1 minus the opposite direction, which is Px is less than or equal to 1. Or if you want to use 2, then it will be x is really less than 2. You get the point?
Yes, sir.
Okay, very good. So less than, so this means, you know, this is the same as less than 1 means, less than or equal to 1 means 0, okay, and 1. So this in actual fact will be equal to 1 minus, okay, I'm using this for explanation purposes. All that I'm writing here, I will write it subsequently. So that will give you P, okay, what you have here is Px is equal to 0, okay, plus P x is equal to what? 1. Oops, did I write x 0? Let me write it well. Okay. My professors, I hope you are following. Then x is equal to 1. But it's the whole of that in bracket because the negative is now affecting 2 of the terms. So as you mature, you know that the negative will affect each term here. So all the terms here after the 1 will be what? 0. So it will be negative, forgive me. Okay, so this will be negative. Let me clear this as well. Okay, so you can see that, like I said, we can move from here to here straight away, just as we have it over here. So it means this is not that critical. Okay, Prof. Christine.
Mr. Hackman, please, I'm getting confused. When we're doing the at least one head, I thought you said this method only applies to that one.
No, no, I didn't say it applies to. Okay, that's not exactly what I said. Maybe you didn't understand what I said. Okay, I said, okay, in probability, anytime you see at least one, P at least one, I wanted you to know this, will always be equal to 1 minus P none. So that one, it will only be one probability that you find and subtract it from the total. Okay, because we realize that if it's at least one, it will be from here down. So the only one will be there. So it will be 1 minus none because none will be 0. Okay, but I cannot say that P at least 2, okay, will be equal to 1 minus none, P none. I can't say that. You get it?
Yes, please.
Okay, so this works for only at least one. If the value here is more than 1 or less than 1, you cannot use, okay, the 1 minus none.
Yes, please.
You get the point now?
Yes, please.
Okay, all right. So now it means this will be equal to 1 minus, let's go and find Ps is equal to 0. Did we do it somewhere? Okay, let's see. If you have done it from the previous one, then I won't. Okay, we haven't. Okay, we haven't. So now it means this will give you 4 combination 0. My professors, I hope you are following. Okay, into 1 over 2 to what power? To the power 0. Then 1 over 2 to what power? To the power 4. Am I right? Then minus x is equal to 1 will give you 4 combination 1 per the function. Yes, please.
If we've done it.
If we've done the 1.
No, the x is equal to 0.
0. Is it from this same question? No, we haven't done it. Oh. We started this same question. No. We started from, if you want to infer from the previous question, then you cannot do that. This question we started from, I think we did it from the NaN. When we use the NaN situation, right? So you are right. We did it here. We did it here. So it's here, not from the original one. I hope you are with me, my professors. Okay, so here
Yes.
my point is I'm going to continue writing because already I've wasted the time, so I won't clear it. You get it?
Yes, sir.
But my point is, if you have done it and it's in the same question, major question, infer, don't stress yourself again. So if I knew the value of this because I've done it, I will go and write the value there. But I've told you it is good to infer, but when you are inferring, it comes with a risk. Okay, you have to be double sure that what you are inferring from is correct. If this is wrong, okay, then it means it will be garbage in, garbage out. Point well made.
Yes.
Okay, so 1 over 2 to what power? To the power 1, then 1 over 2, oops, okay, to the power 3, so cube. Okay, so in this case, this is going to give us 1 minus, let's do it, this one will give us 4. Oh, sorry, in the number combination, 0 is 1. Forgive me. Okay, so now this will give us 1, 1. Okay, so we'll deal with only, I won't write the 1, I won't write the 1. It's simply understood to be there, even if I don't write it. So this will give us 1 over 16. Is that clear? Then minus, this will give us 4. Okay, this will give us 1 over 2. Okay, and this gives us 1 over 8. Okay, so I think from here, you are more than capable, okay, of proceeding. Point well made, my professors.
Yes.
Are you sure you are following?
Yes, please.
Okay, great. Okay, thank you. All right, so now let's continue. Okay, so help me continue. So this will be equal to 1 minus 1 over 16. Okay, then minus,
1
let's
over
do, minus what? 1 over 4.
yes, 1 over
Okay, so this will be equal to, I still trust you to give me the right value for this. Okay, you've not given me more than enough reason not to trust you. Though that one, okay, maybe it's an outlier. So I'm waiting. Your final answer from your calculator. 1 minus this minus this.
1 over 16.
1, what over
11 over
16?
16.
11 over 16.
11.
11 over
Okay, so this becomes what you have here. If you are right, I'm also right. Okay, so take note. I guess my point is well made. At this point, I will pause. If you have issues, okay, please let me know before we proceed to the III. We are burdened. Okay, Prof. Amma.
Mr. Hackman, please, you
Mm-hmm.
said that when maybe we get the answer, we can infer another one.
Mm-hmm.
How do we do it? Should we just write the answer there
Okay.
like the p x equal to 0?
Okay,
We could
so
just write 1 and 16.
going forward, I will tell you what to do because I realize that most of what we needed to compute or we need to compute, okay, we have done it. So I will teach you how to do that going forward.
Like,
Okay, all right. Any other questions? Okay, we thank God. All right, so now let's move on to the I. Okay, so therefore, what are we looking for? P, at what? At least, right? You are still with the at least. At least 3 heads. Okay, so give me the direct inequality. That would be P, X is what? X is, capital X is,
greater than or
greater
equal
than
to
or equal
p.
to 3.
Not equal to
okay.
3.
So now you know, you can even use your fingers. Okay, so this means you do 3, you will do 4. Greater than or equal to 3 will be X is equal to 3, X is equal to 4. I hope you are with me.
Yes, please.
Yes,
Okay, so it means you apply the function how many times?
Twice.
Twice. 1 for 3 and 1 for 4. Okay, you can't go beyond 4. Okay, the opposite direction, you realize that, okay, the numbers below the 3 will be 0, 1, and 2. I hope you are with me.
Yes.
Okay,
please.
and 0, 1, 2. How many? 3, is that not it? So you apply your function how many times? 3 times. But even after applying your function 3 times, that is not all. You still have to subtract it from 1. You get it? So it means
Yes.
here, following the original direction of your inequality is the ideal way to go. If you take the opposite direction, it will mean more work. You work harder but not smarter. Afa, hello, are
Yes.
you with me, my professors? Please respond though.
Yes.
Okay, great. Okay, so now it means we are going to go the normal direction. So this will be equal to P. Okay, x is equal to 3 plus what? Not times, please take note. Plus Px is equal to 4. Okay, so this will be equal to, okay, so let's quote Ps is equal to 3. That will give us, maybe if you have done it, we can infer straight away. Okay, so we are going to infer, okay, without even substituting that into the function. Okay, so let's go back and check. I think when it was the first one, the at least one, we did all that. So at least one here, we did this. X equal to 3. Okay, here is the third one, is that not? So the third term here give us what? 1 over 4. I hope you are with me. So it will be
Yes,
the third
sir.
term here and the fourth term here. Do you agree?
Yes, sir.
So we can infer we are right. Okay, so we knew or we know we are right here, so we can infer with no worry. So I am going to have 1 over 4 plus 1 over 16 written there straight. So 1 over 4, okay, plus this will give us 1 over 16 we have inferred. Okay, so which in effect will give us, I'm waiting for the final answer. Otherwise, if you haven't done it, then we need to go and do 4 combination 3 into half, okay, to the power 3, half to the power 1, plus, okay, 4 combination 4, half to the power 4, okay, half to the power 0. Then now you proceed. All correct.
Yes, sir.
Okay, so now let's go.
5 on 16.
5 on 16. Okay. Okay, this one times 4, so 4. So 5 on 16, you are right. All correct, my professor.
Yes, sir.
Okay, so now we have what? The at least 3 heads. Okay, so we are done with what? The at least questions. Okay, we are going to look at what? At most. How to deal with that. Point well made. All correct with at least so far. So very good.
Yes, sir.
Okay, all right. So
Yes,
now let's move on to the IV, which involves another, okay, adjective. Okay, all right. Okay, so now, okay, we are going to look at IV. IV, therefore, P, probability of obtaining at most 1 head. So at most, okay, 1 head. Okay, so this will be equal to P, okay, probability, okay, of what? X greater than or equal to or less than or equal to?
less than or
Less
equal
than or
to.
equal to. So less than or equal to the value that you've stated here. So X is less than or equal to what? 1. Okay, so it means this is the original direction. So you want to see, if you like your rough work, but I always do it mentally because of maturity. Okay, but very soon, if you are not mature, you equally mature and do it mentally. So you know you are going to your set of possible, possibilities will be, what do you call it? 0, 1, 2, 3, 4. Okay, so if we are looking at less than, okay, or equal to 1, it means we are considering this. So 0 and 1, is that clear? That's the direct inequality. The opposite will be this. You use this 3 and subtract it from 1. So it means the opposite will be more work. I hope you agree with me.
Yes, sir.
So we'll go the direct inequality route. So that will give us, this is equal to less than or equal to 1. So we'll do P, x is equal to 0, okay, plus P, x is equal to 1. All correct? Hey, I've written 0 again. All right, okay, so I've started exhibiting symptoms. All right, okay, so let's go. Okay, so this is what we have. We've done x equal to 0, we've done x equal to 1. So again, we are going to infer. If you haven't done it, you know. It will be 4 combination 0 into half to the power 0, half to the power 4 plus 4 combination 1, x to the power, sorry, half to the power 1, okay, half to the power 3. Okay, so here we have, okay, done that. So this will give us x to the power 0, sorry, x is equal to 0. What did we get? 1 over 16.
Yes, please.
Okay, then plus x to the power 1.
1 on 4.
1 on 4. Okay, so this gives us our final result to be equal to.
Five and 16.
Come again. 5 on 16.
5 over 16.
Okay, just like the other one. Safa,
Yes, please.
okay, so we'll do one more, okay, for the at most. Okay, then I will leave this. Okay, so at most 2 heads. So let's look at that one too. So then you leave a line because we are moving from a sub question to another sub question. Therefore, okay, P probability of obtaining at what most 2 heads at most. Okay, 2 heads. Okay, this will be equal to. Okay, so P, the inequality will be at most, we know the inequality will be less than or equal to. It means 2 is the ceiling. All correct. Okay, so less than or equal to 2 means you do 0, you do 1, you do 2. Is that not it?
Yes, sir.
Okay, so how many times will you apply your function?
3.
3
3 times.
times.
The opposite, how many times will you apply your function?
2 times.
Twice. So that will be better. Though you subtract it from 1, it's better. You get it?
Yes, please.
Okay, so we'll go the opposite direction. So now we know this will be equal to, okay, 1 minus the opposite direction, which will be greater than what? It's really greater than 2. Okay, which is greater than or equal to 3. So that will give us P x is equal to 3. Okay, minus P x is equal to 4. If you do this, you get to know the other, okay, ones left. So you subtract it from 1. Now you've done x equal to 3, x equal to 4, so you can still infer 1 minus x equal to 3. I want someone to give me the value.
1 on
1 on
1 on
4.
4. Okay, minus x equal to 4. 1 on 16.
1 on 16.
Okay, so at this point, calculator all the way. Okay, so that will be equal to,
15 on 16.
okay, 15 on 16. Okay. Professors, I hope so far. Okay, so any questions at this point? Those who are not following, please, okay, don't sit aloof. Okay, let me know. You know you don't have time. When you go back to school, your teachers will not have this time to walk you through this for you to understand, especially in a situation that they have a lot to do. Okay, my prof. Prof Ama, Ama, is that you?
Yes, please.
Ama
Please,
Yabo,
I got 11 over 16.
from this subtraction.
Yes.
Hey, you people, you want to please, is it 11 on 16 or 15 on 16?
It's 11 on. No, it's
11.
You are giving me reason to doubt you.
11 on
11.
16.
Hey,
11 on
you,
16.
all right. Okay, so this is what we have. Okay, second one, third one. The next time you give me the wrong guy, it will give me the indication that you are not reliable. So I will think through before writing the answers. Okay, so 11 on 16. I've told you this calculator work. Did you know why? Calculator work no baby. No, it shouldn't be. All right. Okay, so if this happens to be your rough work, please don't forget to strike it out. Okay, so the rough work for this one was, okay, we did 0, 1, 2, 3, 4. And we said that it will be here. Okay, so here up to here. So the opposite direction will be better. So it will be 1 minus P3, okay, which is S equal to 3. Okay, then minus P4. This is the original direction. Okay, the opposite direction will be this. Okay, Prof. Adoma.
Mr. Hackman, please, you see the ivy at most one head, so the opposite direction would be 2, 3, 4, or
At most what?
one head.
Uh-huh.
I thought the direction would be in the opposite
No, the
form.
opposite will be 2, 3, 4. You are right. But 2, 3, 4, how many times will you apply the function? How many times? You apply it for 2, for 3, and for 4. So 3 times. You get it? Okay, which will be more work than you going the 0 and 1. 0 and 1, you do it twice for 0 and for 1. So the actual direction in the question is ideal. Don't go opposite direction.
Oh, okay.
You get it now?
Yes, please, I do.
Okay, great. All right. Okay, so now we are going to look at what the B. Okay, we are really on course. If indeed you are not deceiving me, okay, if you have understood, then we are really on course. Okay, it means the future is very, very bright. Okay, especially when you start dealing with questions. I mean, past questions. Okay, the technicalities are what I'm making known to you. Okay, so now what do? We are moving on to B. BI. What are we giving? Probability, so therefore P. Let's go. At least. One tail.
B.
Is that okay? Okay, one tail. In terms of, you can see that here it is at least one. At least one. Okay, so at least one tail. Okay, if you want to take it to the relation that I gave you, how would you state it? Before we come to how best to carry out your presentation, I just want to know whether you can be smart, or you can bring your smartness to bear.
Can you ask your question again?
Okay, remember I said when we were looking at least, okay, we said probability anytime you have at least one, it is equal to 1 minus P what?
None.
None. Okay, but when we were looking at least one head, then it will be, the none will be referring to the head. You get it? So it will be no head. So if you have at least one tail, it's the same as what? Okay, 1 minus P, no tail. The none will be no tail, not no head. Point well made. Should I come again, my professors?
Yes.
Yes,
Yes, please.
Okay, all right. Okay, so this is it. So please, if you want me to come again, let your yes please be more cheerful. Okay, so this is what I have. Okay, remember I said anytime you have at least, okay, one, in probability, P of at least one will always be 1 minus P none. And the none will refer to, or is in connection with the outcome that we have there. So that's the more reason why P at least one head was 1 minus P none, and it will be P none will mean no head, because we are referring to the outcomes there. So the none will be with reference to the head. However, here this will be, I'm going to write it, but not to. Okay, so this is the same as 1 minus P, okay, no tail. Is that clear?
Yes, please.
Okay, which is the same as, so let me write it here. You are smart, so you should know. So this is equal to 1 minus, okay, P, no tail. Is that not it? You agree? Do you agree now?
Yes, please.
Okay, so this will be equal to 1 minus, can I write a no tail means s is equal to 0? Can I write that?
No, please.
Okay, very good. Why?
If there's no tail, that means there are 4 head outcomes.
Okay, very good. So indirectly she meant, okay, or she's trying to say that because this, okay, outcome is in terms of your failure, not your success, you take this one towards your success. So no tail means how many heads. So this will be P, okay, how many heads? 4 heads. Before you can now go and use the X. Is that clear?
Yes, please.
Should I come again? Who wants me to come again?
Sir, please come again.
Okay, remember, okay, we could have changed, okay, the failure here to success from the beginning. We'll do that anyway, don't worry. Okay, we'll do that as an alternative. Okay, but because we have at least here, we know there is at least one here, we know there is a connection, okay, or a special relation for at least one, which will be 1 minus P none. And none means no tail. You get this point, right?
Yes, please.
Okay, so no tail means 0 tail. You get it? 2, is that not it? And remember what we did. Were you with us in our previous meeting?
Yes, please.
Okay, so remember I said, if your probability that you have the outcome, okay, involved in your probability is not your success, then you have to move from what? Your failure to your success. And I said, if it is exactly what you have there, and you are moving from your failure to your success, okay, this is what you need to do. Okay, the number that you have here, in this case, it will be 0 tail. Subtract it from your number of trials, which will be 4. Subtract it from 4, so that will give you 4. Then you replace the tail with head, so that will give us 4 head. So it means you move from your failure to your success probability. All correct?
Yes, please. Thank
Okay,
you.
so once you have done that, you heave a sigh of relief. Okay, then the rest of the work will be very easy. So now what do? We know this will be equal to 1 minus, 4 head is the same as what? X is equal to 4. Point well made. So which will be equal to 1 minus x is equal to 4. We did it here. And you said that is 1 over 16. Is that clear? If you haven't done it, then it will be 4 combination 4 into 1 over 2 to the power 4, 1 over 2 to the power 0. You should know this. Here we can infer. That's why we are inferring. Okay, so that will give us what? 15 on 16. Am I right? Professors, are
Yes.
you with me? I hope everyone is fine.
Yes, please.
Okay, great. So if that is the case, okay, I'm going to take you through an alternative way of dealing with it. Okay, how to move straight away from your failure towards your success and work with it, because originally that's what you were doing. Anytime you see the question in your failure, you move it directly to the success, then you work with the success. So that's what we are going to look at, the alternative approach. Okay, so the one that sits well with you, you adapt. Okay, so let's go and clear this. Okay, so now we are going to look at the alternative approach. Okay, so let me see my, okay, so I have the next slide there. Okay, so what do we have? We said, okay, so alternative approach. Okay, and the alternative approach to be at, okay, and we are looking for P at least 1 tail. Okay, so this will be equal to, and this is what I want you to do. Please take note of this. Maximum attention, stop whatever that you are doing and listen. Okay, I'm building a certain foundation in terms of your understanding. Okay, if you don't get it, okay, you will struggle. So again, we know head, tail. Okay, 0, 1, 2, 3, 4. Corresponding 4, 3, 2, 1, 0. Okay, now what you have there is in terms of your tail. So I'm looking at least 1 tail, meaning, okay, 1 or more tails. So I'm going to get what? From here going. Is that clear?
Yes, please.
Okay, so you need to get it corresponding in terms of what your success, which is the head. So you can see that this will also cover this correspondingly. All correct? Should I come again?
Yes, sir.
Okay,
Yes.
all right. Okay, so you can see that this was in terms of your failure. You want to get the corresponding in terms of what your success. Okay, and the corresponding, you know, each one and its corresponding. So the 4 will cover 0, the 3 will cover 1, the 2 will cover 2, the 1 will cover 3 for the success. So it means, okay, the whole of this will cover the whole of this in terms of your success. Is it clear now?
Yes, sir.
Okay, so in terms of your success, very soon I'll give you a simple trick. Okay, not to even do this, you get it. Okay, I mean, do this analysis, but as always, I want you to get the understanding so that in case you forget, you know how to build your point. Okay, all right. So in this case, okay, if you look at this, can I say that what I have here, the probability here is the same as, okay, at most 3 hertz.
Yes, please.
You agree, right?
Yes,
Okay, so
please.
in terms of the success, it will be P at most. Okay, 3 hertz. Okay, I will give you a certain advice very soon. All correct. Okay, so please, are you with me? So I think we've now gone back to our comfort zone. Okay, what we were dealing with. So it means this will be equal to at most 3 means what will be the inequality? Let's go and build the inequality because we can use our x. X is what?
X is less than or
Less than or
equal.
equal to 3. So let's look at the original direction, whether that would be ideal or the other direction. Okay, so less than or equal to 3 will be 0, 1, okay, 2, 3. Am I right?
Yes, please.
Okay, which will be how many times? Okay, the function will be applied.
4.
4.
4
Okay,
times.
meanwhile, the function must be applied 5 times. So it means you are left with 1. So it means the other direction, which is the 1, will be best. Okay, so that will be equal to 1 minus P. The other number that is left will be 4. So it will be P4. Afa.
Annie.
Okay, so indirectly, you can see that I've done this work for you. Or we've done this work together. At most 3 is what we have here. You can see that. Okay, so let's go and continue. So this will be equal to 1 minus PS is equal to 4. Okay, oh, I wrote 4. Let me be consistent. So it should be S equal to 4. But the meaning is the same anyway. Only that for consistency's sake. Okay. So X is equal to 4. Forgive me. And that gave us what? 1 on 16. All correct. So this
Yes,
will
please.
again give us 15 on 16.
15 or 16.
Safa.
Yes.
Okay, so we are going to do one more, okay, for the at least 2 tails. Then after that, I will give you a certain information will come out clearly. Then I will see whether you'll be able to relate, okay, as well. Okay, Prof. Adoma.
Mr. Hackman, please. I'm a bit confused with like the first method and the second method. Aren't they the same?
No, they are not the same. Okay, they gave out the same result, but they are not the same. The first method, look, I'm going back. The first method, we didn't straight away move from the failure to the success. We wrote the failure, okay, here, in terms of another special relation in terms of the failure, before we moved to the success. Can you see that?
Yes,
So
please.
with this one, we didn't directly move, okay, from the failure to the success. We gave a special relation for this failure statement, okay, before moving it to the success. Okay, however, with this one, okay, right from the failure statement, we move to the success statement before dealing with it. You get the point?
Yes, please.
Okay,
And
very good.
which one is more ideal?
You decide. You should know. Now you know how to determine which one is ideal. So which one will save you time, which one will save you space. You get the point. So I will take that
Yes.
as a rhetorical question. Okay, so this is what we have. We are going to move on to the II. Okay, so II, again, we'll do a bit of analysis, like I said. Okay, very soon we'll be done. I think you are doing well. Not that I think you are doing well. Okay, so therefore, P, what are we looking for?
At least.
At
uh,
least 2 tails.
at least, okay, 2 tails. Okay, let me look at the time whether I can give you that information. Okay, I think my time is almost up. So let me quickly give you that information. So if you want to change from your failure to your success, anytime you have at least, the at least changes to what? At most. Then you subtract this one from the end, then you write your success. Just as you saw here, at least will change to at most. Okay, then you to subtract this one, you go back to subtract this one from your number of what? Trials, then you bring your success. So this will be the same as P. Let's go. At most, I hope you are following. At most, you subtract this one from the 4. Okay, that will give us what? 2. Then you get 2x. Safa.
Yes, please.
Okay, so this will be equal to, okay, at most 2 in terms of now you see your success. So you can bring in your x. So x must be what? Less than or equal to what? 2. So which direction? I think we've done at most 2, right? Yes, we've done at most 2 hairs. So you can proceed from here. Is that clear?
Yes, please.
Okay,
Yes.
so I am moving on to this one is the at least in terms of your failure. Let's do, okay, let me ask you this. Okay, at least 3 tails. If you change it to the success, that would be what? P what?
At
At
most
most
one
one
head.
head.
At most
One head. Okay, so you should be able to, you are doing well. Okay, so now let's move on to the at most in terms of the failure. So I'm skipping the I. So we are going to look at the IV. Okay, IV, what do we have? Therefore, P, at most. How many tail? 1 tail. Okay, so remember, okay, because of time, I'm equally going to. So we said at least, okay, will become what?
At
At most.
most.
So at most will become
At least.
at least, as simple as that. So you are moving from your failure to success. So that's when that will come in. So it will be P at least.
3
Okay,
heads.
then you subtract this one. Okay, let me be consistent. You can write 1 here, but once I've written it, I don't clear it, and it will just be a wasted okay effort. So now what do we do? Okay, it will be at least okay. What? Subtract this one from the total end, so that will give us 3. Okay, then heads. Okay, and from here we've done at least 3 hairs somewhere. At least 3 hairs, so you should be able to proceed. So this we know is the same as P. X is what? Greater than or equal to 3. Am I right?
Yes, please.
So you can
Yes.
continue. Okay, so, okay, the last one. Okay, V, you can continue. Okay, so V, okay, will be, therefore, P, what are we looking at?
At most 2 tails.
At most. Okay, 2 tails. Okay, will be equal to. Okay, so
At,
let's change. It's in the terms of the failure, so let's change. That will give us
at least 2 heads.
at least. Okay, 2 hairs. Do you agree?
Yes.
Okay, so which in terms of the inequality now we can use the x because in terms of our success. That will give us P x what?
Is greater than or
Equal to
equal
2.
to 2.
Okay, so you use the direction, whether direct one or the opposite will be better. Then you continue from there. Safa.
Yes.
Okay, so your assignment, okay, will follow from this. Okay, I will send you your assignment. Okay, and please, okay, any question before I finally bring the curtains down? I need to give you some time to reorganize yourself for the next class. My intention was to end as 25. Points well made, my professors. Is everyone okay? Hello?
Yes, please.
Okay, very good. So I'll make the video equally available, okay, for you. Okay, so thank you very much, okay, for your attention and your, okay, time. God bless us all. Have a wonderful weekend.